Hello, I'm Julia Strout, a graduate student at the University of Texas at Austin.
I'm Zeyuan Hu. I'm a first-year master student at UT Austin.
Together, we are going to tell you about our research exploring bias in data using the crowd. In 2016, Baidu and Google spent somewhere between $20 and $30 billion developing and acquiring artificial intelligence and machine learning technologies. A range of other sectors, including healthcare, manufacturing, and education, are also predicted to adopt these technologies at increasing rates. Machine learning and AI are proven to have the capacity to greatly improve lives and spur innovation. However, as society becomes increasingly dependent on these technologies, it is crucial we acknowledge some of the dangers, including the capacity for these algorithms to absorb and amplify harmful cultural biases. Algorithms are often praised for their objectivity, but machine learning algorithms have increasingly made news for a number of problematic outcomes. One example is when Google Photos released a photo recognition algorithm that classified African Americans as gorillas. ProPublica also released an expose of software used in the United States judicial system that is biased against African Americans. These harmful outcomes can be traced back to the data that was used to train the models. Machine learning puts a heavy premium on data quantity. Research communities generally believe that the more training data there is, the better the learning outcomes of the model will be. However, unless extra care is taken by the researchers, these large data sets will often contain bias that can profoundly change the learning outcome. Even minimal bias within a data set can end up being amplified by machine learning models, leading to skewed results. Recently, researchers have begun examining data sets to discover what cultural biases may be incorporated in the data. When Jieyu Zhao and her co-authors from the universities of Virginia and Washington explored Microsoft's image recognition dataset COCO, they found that 37.9% of nouns strongly favored men. Nouns related to sports, for example, were strongly biased towards men, while kitchen objects were strongly biased towards women. They also found that this bias was amplified by a model trained on the data. The same researchers then looked at IMSA2, a visual semantic role labeling dataset, and found that almost 47% of the verbs strongly favored a gender. Words like shopping, microwaving, and cooking were strongly correlated with the female gender, while words like driving, shooting, and coaching were strongly correlated with the male gender. When a model was trained on this data, 47.5% of the verbs saw an amplification in bias. Examples of racism, ageism, and sexism have been found in a variety of datasets, including word embeddings gathered from Google News and crawling the internet by research teams like those led by Aylin Kalaskan at Princeton. The question we ask as we approach this problem is, can the crowd be used to help predict what cultural stereotypes may be biasing a dataset? The goal of our research is to contribute information about how useful the crowd is at anticipating stereotypes that may be biasing a dataset without a researcher's knowledge. So, why use the crowd for this task? One of the key difficulties in preventing bias is knowing what to look for. The varied demographics of crowd workers provide an extended range of perspectives that can help uncover stereotypes that may go unnoticed by a small group of researchers. We conduct our research by asking workers on Amazon's Mechanical Turk to complete two similar human intelligence tasks by suggesting stereotypes related to their own personal experience. We frame our experiment around an image recognition dataset and ask the crowd for ideas of images that could exhibit cultural stereotypes. These suggestions can then be used as a starting point to search for bias within a dataset and potentially introduce new data to counteract the stereotypes.
We designed two questionnaires for our heat task. Both questionnaires ask a set of demographic questions and a set of bias-related questions. Demographic questions include country, language, race, age, and gender. For questionnaire 1, the bias-related questions first ask workers to select a category from race, gender, class, and other. Then we ask them to provide a stereotype that is associated with each category that the workers pick. Questionnaire 2 is designed similarly as questionnaire 1. However, we ask them to write out the stereotypes that they may observe from imaginary photographs. Statistics from our heat task is presented in Table 1. Specifically, we draw a box plot of the average task time of workers. We think average task time is an important indicator of the work quality done by the crowd. As you can see, workers spend more time on questionnaire 2 than questionnaire 1, which is the result of several design techniques we find. Our goal of research is to get diversified suggestions from the crowd on the types of bias we may look into during the machine learning dataset collection. Word cloud on the left shows the word frequency of the workers' response. As you can see, gender, race, and class are the topics that the workers talk about the most about bias. Table on the right shows several interesting bias suggestions that workers come up, which surprise us. For example, a worker thinks it is a gender bias when the pilot on the airplane is a man. We further quantify the type of bias for each topic. Table 4 shows word counts given the appearance of topic words within sentences. For example, among all the bias suggestions with word woman, workers type word kids and children 10 times. This suggests that workers link woman with family a lot.
The crowd demonstrated some modest abilities in being useful for this problem, but this method would require a research team that is highly motivated to weed out bias in a dataset and willing to invest in a fairly time-consuming task. While some workers did bring stereotypes to our attention that we hadn't thought of, the large majority of suggestions from the crowd were uncreative and repetitive. The results suggest that the crowd struggled with the level of freedom and ambiguity inherent to our task. Some of the poor results were due to bad worker behavior, but others seemed to be giving a solid effort. This made determining how to accept or reject workers' suggestions problematic because it was often difficult to ascertain whether the worker was willfully avoiding completing the task correctly or whether the task was beyond them. The problem of bias in machine learning is a complex issue, and we hope that this research will add to the discussion. While we would not yet recommend our exact strategy to other researchers, we hope that this experiment will point out some of the difficulties of using the crowd in this important area.